Hi everyone, I am Darshan from Sri Venkateswara College of Engineering, Department of Computer Science and Cybersecurity. Now we discuss about the topic is phase velocity and group velocity. Phase velocity and group velocity. Introduction to phase velocity and group velocity. Phase velocity and group velocity are important concepts in the field of wave mechanics. They describe the behavior of waves and how they propagate through a medium. Understanding phase velocity and group velocity is crucial in various areas of physics such as optics, acoustics, and quantum mechanics. Phase velocity is the rate at which the phase of the wave propagates in space. This is the velocity at which the phase of any one frequency component of the wave will propagate. You could pick one particular phase of the wave and it would appear to travel at the phase velocity. The phase velocity is given in the terms of the wave's angular frequency omega and wave vector k. Vp equal omega by k. Phase velocity. The phase velocity of wave refers to the speed at which a specific phase of the wave propagates through space. It is given by the ratio of frequency of the wave to its wavelength. The phase velocity is determined by properties of the medium through which the wave is traveling. Group velocity. Group velocity, on the other hand, refers to the speed at which the envelope of a wave packet propagates. It represents the velocity at which the energy or information carried by the wave packet is transmitted. The group of velocity is typically different from the phase velocity and can even be greater or smaller. The relationship between phase velocity and group velocity. In some cases, the phase velocity and group velocity can be the same, especially in homogeneous and non-dispersive medium. However, in dispersive medium, where the phase velocity varies with frequency, the group velocity differs from the phase velocity. The group velocity can be expressed as the derivative of the phase velocity with respect to the wave vector. Phase velocity, group velocity, and particle velocity. Phase velocity, the velocity with which the phase of the vibrating particle propagates as the wave progresses is called phase velocity. V phase equal omega by k. Group velocity, the velocity with which the wave packet formed due to superposition of two or more traveling waves of slightly different frequency is transported is called group velocity. V group equal delta omega by delta k. Examples of phase velocity and group velocity. In optics, the phase velocity of light in a vacuum is constant and equal to the speed of light, while the group velocity can be manipulated using various techniques. In water waves, the phase velocity is determined by the depth of the water, while the group velocity depends on the wave's frequency and the shape of the wave packet. In quantum mechanics, particles can exhibit it wave-like behavior, where the phase velocity corresponds to the particle's velocity and the group velocity represents the velocity of the particle's wave packet. Applications of phase velocity and group velocity. The understanding of phase and group velocities is essential in the design and analysis of optical systems, such as fiber optics and lasers. In acoustics, the control of group velocity is crucial in applications like soundproofing and noise cancellation. In quantum mechanics, the study of phase and group velocities helps explain phenomena like particle tunneling and wave particle duality. Omega 1 component, omega 2 component, the total component shown in the figure. Conclusion about phase velocity and group velocity. Phase velocity and group velocity are fundamental concepts in wave mechanics. They describe different aspects of wave propagation, with the phase velocity referring to the speed of a specific phase and the group velocity representing the speed of the wave packet. Understanding the relation between phase and group velocities is crucial in various fields of physics. Thank you.